In the era of smart vehicles and the intelligent transportation system, roads are no longer merely a physical entity or a solid ground. In fact, if one looks at emerging economies such as Asia, South America, Africa, which form the bulk of the next generation growth in smart transportation, most of the time the existing roads are not at all conducive to operate a smooth and an efficient road transport system. It is well known that on-road traffic is remarkably influenced by the environment, vehicle parameters, and spatio-temporal factors. It is imperative to have a mechanism that would provide a score for the road, indicating how good or bad the road is for driving the vehicle. We have developed a quantification mechanism.
So what is this proposal mechanism called RQA, that is Road Quality Indicator. So typically we consider lanes, lane markings and potholes, that is where we consider the number of potholes, area of the pothole, length of the pothole, width of the pothole, climatic conditions and driving environments like highway scenarios, urban and rural scenarios, etc. So we consider the graph-based information and we consider the IMU like accelerometer and gyroscope based information, we consider the GPS coordinates, and with this data we try to sync with respect to time frames.
So coming to potholes, out of all the factors that influence the quality of the road, potholes form one of the most important factors, especially for the Indian roads. Detecting potholes and reporting them periodically can not only improve the road quality but also automate various government projects for road maintenance. Specifically, we leverage the real-time object detection research to identify the potholes and estimate their dimension. We utilize multimodal information along with the popular deep lab framework to further push the performance boundaries. We also test our reliability of our systems by deploying them on an Android device.
In the context of a residential and small streets prevalent in many of the towns and cities, a particular road may be perfectly suitable for a two-wheeler, while not being suitable for others such as a three-wheeler or a car, truck, etc. This project has been possible only because of the support from IIIT Sricity and is an outcome of a couple of years of work towards improving the road and traffic conditions, focusing particularly on the Indian roads. We have created a unique and a huge data set for the Indian roads called SIDDI, focusing on the suburban and the rural roads in the South India, such as Sricity, Kalahasti, etc. And with collaboration from Mobility Research Center in IHub, the next stage is to expand to other cities such as Tirupati, Nellore, Hyderabad, etc. This would greatly benefit the National Highway Authority, the Road Research Institute, and also car manufacturers and automotive solution providers to develop the next generation of road and traffic-aware ADAS systems.